I would like to see a day where we don't have to give chemotherapy anymore.
I think we really are in sort of the golden age now. People can be optimistic that what was not treatable 10 or 20 years ago is now something that they'll be able to survive.
Dream big. How can we use science and research to improve the health of everybody?
Progress is moving forward at a very rapid pace. We're learning more and more.
There have been critical breakthroughs building on that knowledge, but there's a lot more we can do.
What we know about basic biology, it's not done by any means. We need to really continue to invest in basic discovery. People talk about translation. You can't translate nothing. You have to have a continued flow of basic discoveries. We're seeing an acceleration in therapies that we refer to as targeted therapies, where our knowledge of the biology is really going to allow us to design new drugs that'll be very effective against cancer. We're really looking to understand really the basic mechanisms of cell proliferation and the basic mechanisms of cell death, and what our ultimate goal would be to get tumor cells to die while protecting normal cells. And you have to know what's unique about cancer so you can get at their Achilles heel and eliminate the cancer cells without making the lives of the patients miserable at the same time. So you want something effective, and also you want to eliminate cancer cells for the long term.
My definition of translational medicine is understanding the latest breakthroughs in cancer research and figuring out ways that we can apply that to our patients. One of the great challenges that I see as a radiation oncologist is that many patients have surgery for a cancer, and in a subset, usually a third or a quarter, there's microscopic residual cancer left behind. But because we don't know who those patients are, we generally treat all the patients with radiation therapy. We applied to the Damon Runyon Cancer Research Foundation with this idea that we could try to image microscopic residual cancer in the tumor bed. They thought that our idea was high risk but potentially high reward, and so they funded that project with philanthropic dollars. My laboratory studies how sarcomas develop, how they spread, developing novel therapies for sarcomas. We utilize genetically engineered mouse models in my laboratory, and what we're able to do is make the same kinds of gene mutations that happen in a human cancer in the mouse genome that we can then translate to therapies for human patients with sarcomas. This is a very powerful approach to understand how cancer develops and how treatments will impact cancer.
Women in my clinic, their question to me is, okay, so you've told me statistically I have this percentage chance of the prevention agent working. But what I really want to know, is this thing working in me, in my breast? And I was like, well, I can't really tell you. So they said, well, figure a way out. So we go in with a very slender needle, we numb up the breast, and then we take cells out. And then do we see precancer or do we not? So what's very exciting for me in prevention is we're able to individualize, and we're able to match that woman and the biology and the bad things that are going on with her breast with a prevention agent that can target what exactly is going wrong. Women whose mothers died of breast cancer don't have to die themselves. When women have gotten cancer, instead of finding large cancers, we find tiny little cancers, and many of the women didn't even have to have chemotherapy because our science has gotten good enough that we can really start to figure out when things are going bad early. We just have world-class science here.
Duke is an incredibly collaborative place.
We go from the community, from the clinic, back to the lab to ask basic scientific questions, and then forward to clinical trials. So there's really a bi-directional sharing of information.
The theme that sort of spreads across all of Duke is this sort of interdisciplinarity and really having people from different perspectives work together. And that's a flavor at Duke that you don't find every place.
People are very willing to work together. They're very willing to share information. They're very willing to work as a team.
A lot of work can sort of move things ahead step by step, but if you really want to make this paradigm-shifting discovery, sometimes you really need to take a big risk.
The philanthropy allows us to go out on a limb and take the risk for our biggest ideas and kind of swing for the fences.
Every dollar that has been given, we've worked very hard to make sure that it came back as many dollars in grant funding.
If you make an investment in an individual area at Duke, it's really going to reverberate because people will work with their colleagues and it will have an impact not only in their area, but in all of the areas in which their colleagues are working.